Okay, moving to supercapacitors. Supercapacitors, you might have already studied. It uses the concept of electrochemical double layer capacitor, concept of electrochemical double layer formation. Okay, the electrochemical double layer, that is one you have to remember. It's also called as EDL. Okay, they are the energy storage device which bridge the gap between the traditional uh, capacitor and batteries. Which one? Supercapacitors, not the ordinary capacitor. They offer a unique combination of high power density, rapid charge discharge capacity, and long life cycle. High power density means very much high amount of energy power can be stored inside. That is called a high power density. And rapid charge discharge capacity means it can be charged fast. It can be used to get electricity very fast, and it has got a long life cycle, a long cycle of life as a life cycle, making them very suitable for a wide range of applications. Okay, now we see the working principle. Not like batteries, which stores in the form of chemical reaction. Chemical reaction takes place, and during the chemical reaction, the electrons are moved to one side, and electrons are stored or giving electrons. And when it is reversed in a reversible battery, the same chemical reaction it gets reversible, takes electrons, and reversible reaction takes place. Those are batteries. Supercapacitors, not like those type of electrochemical reaction, they store energy electrostatically by accumulating ions at the interface between the electrode and electrolyte. It uses ions, not the electrons. Electrons, that is E minus V, right? Electrons, that is movement of electrons. Atom in an atom it has got electrons under. But when an atom it loses an electron, it becomes an ion. Or when it gains an electron, it again becomes another ion. When it loses electron, when an atom or an element it loses electron, we call it as a positively charged one. It loses electron, positively charged ions or cations. So when it gains extra electron, it becomes anions. Therefore, ions are used here. Anions and cations that you have heard. No? So that one it is that movement it is used. Therefore, if an electrode, if a electrode, you know what it is electrode, the one which is usually for plus sign or negative sign, both are the electrodes where the electricity supply is given. So when an electrode, if it is given a positive charge or the electrode is given positive charge is there, that obviously the negatively charged ions will come and sit near to that, or it can be stored in that electrode. And when an electrode it is having a negative charge, that to that side the positive charged ions will go and it will settle or it will store. So that concept is used, and that makes it layer, two layers, one layer with negative ions, another layer with positive layers. Therefore it becomes a electrochemical double layer, two layers. That is a word called electrochemical double layer with opposite charges. Now, during the charging phase, when we have excess energy, that is, we are discussing about renewable energy resources, renewable energy sources. When we have excess renewable energy sources, then we have to go for charging the supercapacitor. That is ion accumulation. We have to accumulate the ions. That means when voltage is applied across the supercapacitor, ions from the electrolyte is the something which has got ions, okay, which migrate to the surface of the electrode with the opposite polarity, forming electrochemical double layer. So this charge separation stores electrical energy. That means when we have excess energy, it is connected to these electrodes. Electrodes are connected to the material which are separated materials having opposite or negative charge, and we have a electrolyte throughout this container, and the negatively charged one goes to one side, the positive charged one goes to the other side through the separator, and or it will settle there. They will not combine, and there is no leakage of current, and the the electricity which is used to make the ions compressed, negative side negatively charged ions to compress to the positive side of the electrode, and positively charged ions are compressed towards the negatively charged electrode, and it get stored there. So that is called a charging phase. Now during discharging phase, that is ion release, when the load is connected across the supercapacitor, means when we want to take electricity from that, the ions move back across the electrolyte, which releases the stored energy. Because to make the ion to store one side, so say called a negative charge ion to get stored to one side, it needs lot of positive charge there. Okay, or if a positive charged ion it is stored at one electrode, means there more electrons are stored. So when the positive charged ions move back to its original state, that means it releases the electrons from there. The electrons become free. Okay, so we get the electrons back. When we are getting electrons back, we are getting the current back to our system. Okay, so now that is what about the working of working principle of the supercapacitor. Now the components, the electrodes use supercapacitor typically use high surface area material like the activated carbon, carbon nanotubes, graphene as the electrode, because they have got more active surfaces compared to other material. More the ions can go and occupy those pores or those areas. So more active surface is the more storage capacity we have. So these materials provide a large surface area for the ion accumulation, and it enhances the energy storage capacity. Okay, so activated carbon, you can check, Google it, what is activated carbon. Carbon nanotubes. Carbon nanotubes means a carbon arranged in a hexagonal shape, then again arranged in a tube shape. Not arranged, they themselves arranged. That is called carbon nanotubes. And graphene again carbon in the form of a sheet, that is called a graphene. They are arranged in a well layered type, six hexagonal arrangement of carbon, and that the layered arrangement we call it as a graphene. So this has got more activated, more high surface area, so that it can be used. Okay, so that is first point, which type of electrodes are used in supercapacitor. Main thing, high surface area material like activated carbon, carbon nanotube, or graphene. Now what are electrolytes? Electrolyte, it is a ionic conductor that facilitates the movement of ions between the electrodes. It can be a liquid, it can be a semi-liquid, or we call it as gel. It can be a solid state material. It depends upon the supercapacitor design and operating temperature. And based on the temperature, what temperature it works, based on what type of design this box has got, the supercapacitor has got. Based on that, I can either use liquid, or I can use gel, or even solid. If it is a very compact material, then we need to go for solid. If it is a little bit bigger one, then we can go for gel. If it is a bigger one, we can go for liquid. That is the meaning, understood. And as well as the temperature material, how it works on different temperature. Based on that, the material, the item used as an electrolyte, it will keep changing. Anyhow, it is the one which has got a free movement of ions from through that, that is called the electrolyte. A medium to which through which movement of ions is possible, that is called the electrolyte. Third one, that is separator. Separator, it is a thin porous separator which prevents the physical contact between the electrodes by allowing the ions to pass through. Okay, we said that there are two electrodes, these plus and minus sign, and inside this connection will be the electrodes. There will be metal rods inside that. Okay, so metal rods means not metal rods. This carbon activated carbon, or carbon nanotube, or carbon nanotube, or graphene. These are the electrodes. They are kept in such a way that they are in a particular distance, and they should not touch each other. If they touch each other, positive negative charge that you are supplying, it will nullify there only. Therefore, it needs a separator, a thin porous separator, which will prevent the physical contact between the electrodes while allowing ions to pass through it. Then there is a current collector. So this conductive component, it connects the electrodes to a external circuit, allowing for charging and discharging of the supercapacitor. That is this plus minus these collectors. Okay, that is called current collectors, where the screw, where we give the connection, that is called current collectors. The graphene and carbon nanotube, that is materials inside electrode. Okay. Now the packaging and housing, what type of material which is used to make this, prepare this box, that about that. It is a sealed container made up of aluminum or plastic to protect them from the environmental factors, heat, exposure, leakage, then strength. All these component, all these terms has to be considered while making this one. Now the materials which are used are mentioned here. Uh, it should be stretchable, it should be wearable, it should be flexible, it should be transparent, it should be micro. These are the functionality needed in the current collectors for the material which is used there. And the carbon based material, if it is, then they are maybe graphene tape, maybe 3D prolytic carbon, it may be reduced graphene oxide, it may be carbon fiber, it may be carbon paper. If it is a metal based, it may be nickel foil or foam, mesh, paper, or three-dimensional nanostructure, maybe copper foil, aluminum foil, gold leaf, Venetian, silver grid. So some of the examples, no need to by heart those things, only to remind whenever future, whenever you think about supercapacitors, some knowledge you want, you can think that these are the materials. Right now it is used, and a lot of research is still going on to improvise the storage capacity and the speed of storage, speed of getting back. We know our mobile and all, we charging by 5 minutes it should be 100%, and that type of storage, and if you have a device to store the current, power bank is there, 5 minutes the power bank has to be completely full. Like that, our requirement never ends. So therefore the materials also needed to satisfy those things. Therefore material science is also very important. What type of materials are required, that also very important. If it is not there, we have to make such type of materials as per our requirement. Then merits and demerits. It has got a high efficiency, up to 90%, very fast response time, faster than batteries. It has got long lifespan, it can withstand many charge discharge cycles. Demerits are, they are a low energy density compared to batteries, so it can store less energy per unit volume. It has got limited storage capacity compared to other methods. These are the merits and demerits. Regarding batteries, next video.